Hello A&P students, my name is Eric Barn, and today I'm going to be teaching you guys how a neuron fires. So if we look at the problem on the screen now, so imagine we are a motor nerve signal being sent through a neuron. What are the different steps in our journey that are going to happen before we're passed over to the next neuron? So the way I like to think of this is if we're that action potential that's traveling down the neuron, I like to think of us as getting more and more excited as you go through the neuron. So if you look at this drawing right here, let's orient ourselves first before I start explaining. So if you look at the D right down here, that's going to be for dendrites, and those are going to be drawn in blue right here and right here. Then S is soma, drawn in red right here, and then axon drawn in green right here. Okay, so our journey is going to start here at the synaptic cleft. So we have these two end motor plates of different neurons that are releasing neurotransmitters into the synaptic cleft. And you can see them here. They're going to bind to this channel right here. This is going to be a sodium ligand gated channel, and it's located in the dendrites, like you guys should know. And once that happens, the sodium is going to rush in, and this is where our journey starts, is in the dendrites. So if we imagine a graded potential here, I'll draw one in so that it's like a little bump, and it'll get bigger and bigger and bigger as more sodium rushes in. And so we're going to get more excited and more excited, and we're going to move, as we get more excited, down this way. So as we get more and more excited, more and more sodium's rushing in. We can also have these channels in the soma here, so I'll draw that in. So those channels are also going to be letting in sodium, and we're going to get more and more excited until we reach a breaking point. And that breaking point is going to be at this dotted line right here, and that's going to be the axon hillock. So that's where we're going to wait for all of our graded potentials. So that's where we're going to wait for all of our graded potentials to build up until a threshold. And then once they get to that threshold, it's going to shoot down the axon super fast, and you're going to get so excited that you can't contain yourself, and you're just going to rush down the axon. Now once you get so excited that you rush down the axon in this direction, you're going to get so excited that more channels are going to open and invite more sodium in to get even more excited as you travel down the axon. And that's going to happen right here at the location of this channel. So if you guys know this channel, I'll give you guys a second to name it. So this channel is going to be called a voltage gated channel, and it's going to be in response to you being so excited that it's going to open up and then invite more sodium in. So sodium's going to come in that direction, and it's going to make you even more excited and rush down the axon that much faster. And then as you get towards the end here, you're going to get towards the end motor plate right here. And then once you get there, you're going to cause neurotransmitters to come out of the end motor plate and into the synaptic cleft here. And then another axon's dendrites can use those neurotransmitters to continue the cycle. And that's how you as an action potential would go down the neuron. So now, going back to these purple things on the axon. So what are these? If you guys know, I'll give you guys a chance to answer really quick. Okay, so these are going to be myelin sheaths, and these are going to be in both the peripheral nervous system and the central nervous system, but they're going to be a little bit different in each system. So in the peripheral nervous system, they're going to be called Schwann cells, and they're not going to cover the entire axon. And then in the central nervous system, you have oligodendrocytes, which will cover the entire axon, and both of these will help in conduction of that nerve signal. So we're going to be in the peripheral nervous system because we can see that these purple cells aren't covering the entire axon. So let me write just peripheral nervous system up in the corner so we know. And then these are going to be myelin sheaths. Okay, so these myelin sheaths are also going to contribute to you firing down the axon as fast as possible. And that's going to be known as the process called saltatory conduction. So during this process, you build up at these things called nodes of Ranvier, which are going to be right here and right here. And they're in between those myelin sheaths. So when that charge builds up, you get more excited, and then you're going to jump across the node really quick, and then you're going to get more excited in about this area, and then you're going to jump across here. And it's a super fast process that happens. Now all this is going to be happening in the fraction of a second. We're just breaking it down into multiple different steps. So this is all I wanted to talk to you guys about today. So thank you guys for your time, and have a great week.